Okay, let's get started with solving equations with radicals. Now we're going to start by solving equations with one radicals, and the steps are very simple. They are: isolate the radical, raise both sides of the equation to the power equal to the index in the radical. In other words, if you have a square root, you will square both sides. And then simplify and solve for the variable. There is one step I want you to consider that we did not write down. In fact, don't just consider it, it is required. You must check all of your answers to make sure that you do not have an extraneous solution. All right, well, let's get started with our first example. We will start by isolating our radical. In this case, we will divide both sides by 2. We will square both sides. Then we will simplify by subtracting 1 from both sides and solve. In this case, x is equal to 48. Now, remember, I said that there was a required step, and it is to check your answer. So we will substitute our answer of 48 back into the original equation and solve. And we see that when we do that, 14 is indeed equal to 14, so this is the correct solution. Pause if you need to right now. We'll go on to our next example in the notes. In order to isolate this radical, we need to subtract 4 from both sides. So we do that, and we end up with the square root of 1 is equal to 1. We will square both sides, and then simplify and solve for x. In this case, that means adding 1 to both sides, and we end up with x is equal to 2. Now, we won't forget to check our answer, so let's do that right now. If we substitute in 2 for x, then we end up with 4 plus the square root of 2 minus 1, which is 4 plus the square root of 1. 4 plus 1, that's 5. It's equal to 5, so we have a solution that works. Now, let's go to our next example. Okay. A lot written down here, but don't panic yet. Let's take a look. In this case, we have 2 radicals. So what do we do in that case? Well, we will not be able to isolate it down to 1 radical on one side of the equation, so we will simply begin by squaring both sides. Squaring both sides. When we do that, we end up with 35x is equal to 25 times x plus 2. Please don't forget to square the number. In this case, it was 5. That gets squared too and becomes 25. Now we are going to simplify and solve. So we will subtract 25 from both sides, divide by 10, and end up with the answer x is equal to 5. Now let's see if that works. When we substitute 5 in, we find that 35 times 5 is 175. That can be factored as 25 times 7. We know that the square root of 25 is 5, so that can be simplified to 5 times the square root of 7. On the other side, we have 5 times the square root of 5 plus 2, which is 5 times the square root of 7. So we have a match. We have a good solution. Pause now and take more notes or complete your notes if necessary. Okay, let's go on. Our next example. Another example with a radical on each side of the equation. Let me scoot that down a little bit so you can see it. Here we have a radical here and a radical here. In that case, we square both sides, simplify and solve. In this case, x is equal to 6. Now let's check our answer, because we always want to check our answer. X is equal to 6, so we will substitute x into our original equation here. So we have 48 plus 6, square root of 54. 54 can be factored to be 9 times 6. Oh, so that ends up being 3 times the square root of 6, because the square root of 9 is 3. All right, well, we already knew this one was square root 3 times the square root of 6, so we have a match. This answer checks out. Let's do the last one on this page, but before I do that, pause this video and complete your notes with this example, and note any questions you have, if necessary. Okay, so let's go on. Now, in this case, we do only have one radical, and it is already isolated. So what do? Already isolated, well, we go ahead and square both sides. Now, notice that this is a binomial. It ends up being x minus 2 squared. We have to FOIL that. So let me quickly show you that, what I'm talking about. If we're multiplying x times x minus 2 times x minus 2, then we do first, outer, inner, last. We combine like terms and end up with x squared minus 4x plus 4. Okay, so that's how I got here. Now we're going to simplify and solve. When I simplify, I end up with a quadratic equal to 0. I have to solve for x, and I only have a few options for how to do that. One of them is factoring, and I would recommend that you try that first. So I'm going to look for the two numbers that multiply to be negative 14 and add to be negative 5. They are negative 7 and 2. Those are my factors. I set each one of those equal to 0 and solve. And I get x is equal to 7 and x is equal to negative 2. Let's check both of those answers. If x is 7, then I end up with the square root of 25 is equal to 5. 5 is 5. That checks. If x is negative 2, then I end up with negative 4 on this side and the square root of 16 on this side. That ends up being 4 and negative 4. They will never be equal, so that solution is extraneous. Okay, two more solutions, two more examples, and we are done. Remember that you can pause this video at any time and take additional notes or finish out your notes as you need to. So let's take a look at this one. Oh, it's in a little bit different format. A little bit different. We have x plus 2 to the 1/2 power. Well, what is that? You may recall from the laws of exponents that anytime you have a fraction that's an exponent, that the index is the denominator, or 2, and the numerator is the power on the radicand. So we have here the square root of x plus 12. Now we don't write the 2 as the index. If it's blank, it just defaults to 2. All right, so this is what we have. Well, we know how to work with that. We'll square both sides. We will simplify and solve for x, and in this case, x is equal to 4, x is equal to negative 3. Let's check our answer. Move that over. So if x is 4, then I end up with the square root of 16 is equal to 4, and you can already see that's going to check out because 4 is definitely equal to 4. In this case, I have the square root of negative 3 plus 12 is equal to negative 3. You know, I know before I even solve this that this is not going to work out because I will never end up with a negative value on this side of the equation as it's set up right now. The square root of 9 is always going to be positive 3, and so I have an extraneous solution. Pause now if necessary. Okay, our last example here. Let's see. We have another one written with a rational exponent. So by now we know that this is equal to the square root of 2x plus 15. So we will square both sides. Simplify. Factor. And solve. Then we're going to check our answer. Now if x is equal to 5, then I have 2 times 5, which is 10, plus 15. That means the square root of 25 is equal to 5. That checks out. The other one is 2 times negative 3 plus 15, so that would be the square root of 9. It's going to be positive 3. That's never going to be equal to negative 3. It is extraneous. All right, now pause or rewind, whatever you need to get all of these notes. Also, if you have any questions at all, please note them right here on your notes. This is the first thing we'll be discussing in the next class.